This is just a disclaimer to let you know that this video is not intended to be imitated. No parts of it should not be copied or done by you or anybody. It's just for educational and maybe entertainment purposes to watch. That's it. I don't condone anyone repeating anything in the video. This is John Black, super chemist, here to make some 1,4-dioxane. Before I get into how to make that, I want to go over how to make diethyl ether. Okay, this is the mechanism for it. You got alcohol, your ethanol, right, and you have your acid, sulfuric acid. I just put a proton there. You protonate the alcohol so that you have a water group, right? That makes this oxygen oxonium ion, which means it's positive. And oxygen is electronegative. So it likes to be negative. So it's going to grab some negativity off of this puny carbon here, making it positive. So another water molecule, see down here, or alcohol molecule, can come up with its lone pair electrons and tag them onto that positive, partial positive carbon there. And that can kick off the water group, right? Now you come over here and you got your water and you got this. Now you have another oxonium ion. So the electrons go to the oxygen and you get a proton, right? You started with a proton, you ended up with a proton. So you got, this hydrogen sulfate that pulled off, that's the anion. So that's why we call that the catalyst, because it doesn't do anything. I mean, it does something, but it comes back. It doesn't get used up, like, theoretically. So here's your product, diethyl ether. Now, I want to show you the mechanism to make 1,4-dioxane. Watch what I'm going to do to this. I'm going to change it so that it becomes how to make 1,4-dioxane. Okay, do you see what changed? I changed the ethanol into 1,2-ethane diol, which is, most people call it ethylene glycol. Most people call it ethylene glycol. That's the stuff you put in your antifreeze for your car. All I did was add that extra hydroxyl, because that's the only difference between antifreeze and vodka, right? You have an extra hydroxyl on the other carbon. It's doing the same exact thing. I didn't change anything. All I did was put an OH on all these. That's it. So how do you make 1,4-dioxane? Everything I just told you, replace ethanol with ethylene glycol, right? Now when you get your diethyl ether, you go down here. This is what diethyl ether, see how it says, this is diethyl ethyl true, the same thing, right? What happens if the proton comes and look at that, these are the same. This is the same as that, this is the same as that, this is the same as that. A proton comes, protonates the OH, just like up there. It's not another ethanol, it's the same ethyl group. I mean, it's the same molecule, but it's a different ethyl group. See how it's the same thing? It's an intermolecular reaction, right? Same thing, the electrons come up to get the positive carbon, and it's positive because the oxygen was positive, and it's electronegative, so he took some of the negativity and left carbon positive. The water kicks off, just like up here, and you have an oxonium ion with a proton, so that's easy. The proton goes away and you're left with what you got, just 1,4-dioxane, and your proton or your acid is replenished. Alright, in this bottom flask here, I got it in an ice bath, and I have some antifreeze in there, some ethylene glycol. Up here, I have about 20 milliliters of concentrated sulfuric acid, and I'm going to drip it in at a very slow rate. Everything was chilled down in the, well, actually just the chemicals were chilled down in the freezer. Let me tell you, that ethylene glycol, it's like surf when it gets that cold. I gotta stir water. I'm gonna set that up. Make sure it stays cold. You notice every time I put sulfuric acid into an alcohol, I always do this setup. Whether I'm making an alkyl halide or ether, I'm just going to drip that in, and when it's all dripped in and warmed up to warm temperature, we'll distill that out. Oh, there it is. I got it already set up and going for the simple distillation. You can see. Starting to bubble. Well, it's been bubbling actually. It's already up to here. I'm just going to let it drip around that rate or slower until it's, everything's over there, it foams up or, starts getting disgusting. See, it's definitely black in there, in the pot. I'm trying to do it as long as I can. This pot's dark as heck. I'm almost done with this distilling. See how much is in there. Much is in there. There's actually more to distill. You look in there, you can see it's still liquidy. I don't know if you can see it on camera. There's a lot of solid in there. I'm just like tired of distilling. I just want to quit. Plus the drip rate slowed down. Oh, it's pretty much stopped now. Jacked up the heat. There it goes. Alright, I'm going to do this maybe a couple more minutes and I'm going to call it a day. Well, there's my stuff. Most people that distill it know when you get that foam, they keep distilling and distilling until it actually almost jumps over to the, through the condenser. I mean, as soon as I see it inching up, that's it, I'm done. So I probably could have got more. This is crystal clear, but I don't know, you can see it on film. It's got a yellow tint to it. That's why I put the white background. But anyways, this next thing, basically I got to give it to Nerd Rage because I never would have figured this one out. Is to put some sulfuric acid in there. So I'm going to pour 10 milliliters of sulfuric acid in there, just a little at a time. Had it in the refrigerator, so it's cooled down. It's actually still cold. Well, that's it. I'm just going to set it for distillation. I'm going to make sure that this has warmed up because it's actually still cold. And that's it. The sulfuric acid does, I guess, it acidifies and hydrolyzes some of the impurities and, gets them out of there. Some of the side products. Well, it's only been like 2 minutes or something, maybe 3 minutes. You see that spot in the middle there? That's not the... That's some kind of, maybe it's polymerizing it or something, I don't know, but it's getting rid of some of the impurities, I guess. Maybe I should have shook it around. Anyways, I just wanted to show you that it is getting rid of something. Here we go. I'm set up for put the Vigorex column on there. Got a nice bath over here. Water cooled condenser. I'm gonna get all the low boiling point stuff out of there, and then the azeotrope boils at like 87.6 Celsius, or somewhere around there. Maybe 4 or 5 degrees before that and 4 or 5 degrees after that, I will collect for my stuff. This low boiling point stuff is just crap. But you can see it's already coming out of the steel heads only at 30 degrees. That glob that was in the bottom there after I put the hydrochloric acid in, mixed with it, and now it's even more yellow. You can really tell it's yellow. Anyway, that is the azeotrope we're getting out of there. I'm halfway through the distillation. You can see it. It's yellow coming out. I don't know if you can tell. But it's definitely not white. I mean clear. I mean it's clear, but it's got a yellow tint. Like I said, I've got about half there. Probably half there. Got a pretty good shot of that front. Oh, got a little blast there. So you can see how it's just barely going over. Alright, here's the deal. This is the pot. This is what I got. This was the low boiling point stuff. I have to get that at the bottom, see how there's very little. You should never smell chemicals. Yeah, it smells like acetaldehyde.